Okay, looking that our environment is good now. Right now I want to show you how to do some forensic using autopsy, because our mission on the Picoctf right now is doing forensic. Okay, let's check it out. I will hide my video and let's go to picoctf.org. Okay, we are on the dashboard page on Picoctf. Let's do login. If you doesn't have a username or an account on Picoctf, you could register there. And right now we have Sleuthkit intro. Sleuthkit is the tools for doing some autopsy forensic. Let's check it out. Download this image, access the checker program. Okay, Sleuthkit intro 100 point, authored by Lieutenant Cyril Jones. Hints nothing. Download this image and use MLS on it to find the size of the Linux partition. Connect to the remote checker services to check your answer and get the flag. Note: if you are using web shell, download and extract this image into /tmp, not your home directory. Download this image. Let's copy the link to the image and NC Saturn, and let's take a look the mission. First, we are on Kali. I have a Kali box. In here, I will make some folder: CD desktop, CD Picoctf, and listing here. Nothing folder here. Clear, and we are using the sleuth. Let's make directory forensic and change to the directory. Listing here, we get the image here. Download the image here, and let's inspect, copy, and next the netcat location. What is the size of the Linux partition in the given this image? Okay, this time image means not the like a PNG or JPEG file. Image here is this image. I will show you what is the meaning of this image, and we can do some browse. What is this image? This image is a snapshot of storage devices structure and data typically stored in one or more computer files on another storage device. It's like some storage devices that contain any files on it. And what is this used for? This imaging is process of creating a byte by byte archive of a hard drive, producing a compressed file on your drive, much like a .zip file, although typically saved as an ISO file, and storing it in another drive. These compressed files are still huge, so they are often saved to the external drive or the cloud. Okay, it's unlike a external drive. So we got the clue here. Use MLS on it to find the size of the Linux partition. Okay, we got that, and let's check what is file is. File. This image is this image gazette compressed data. What's this images last step modified? Okay, I will clear the terminal and do some extracting. Decompress this image, and let's check the file this image. This image DOS MBR boot sector partition 1 ID OX83 active start CSV start sector about and have 22752 sector. Let's using MLLS. This is missing image name, so we can type the image type list list raw update okay. MMLS. What is MMLS? Manual page about the Sleuth Kit. Display the partition layout of the volume, partition table synopsis. Okay, we can do some MMLS and the image DD. Okay, we check by MMLS and this image, and we got those partition table offset sector 0 units are in 512 byte sectors. We have description here, primary tables, the 0 unallocated and Linux allocated with length of 200. Okay, what's the mission is access checker program. Okay, look like the NC want me to tell how what is the size of the Linux partition in the given this image, length in sectors about the Linux. We got this. Let's copy this and paste it here, and it works. We got the flag here. Okay, we are copy here and paste it to our Picoctf and submit the flag. Right, you earn 100 points. It's look like we are doing something great here, and we still have this load. This load, this is the second one. We get the Sleuthkit apprentice. We have 3 like the same mission here, 1, 2 and 3. Look like the last is 200 points, but this look like the hard things. Let's do this one. The second challenge about this load, use srch strings for the Sleuth Kit and some terminals foo to find a flag in this image. Let's take the hint. Have you ever used file to determine what is the file was? Yes. Relevant terminal foo in Picoctf. It look like the directing about the challenge 85. Mastering this terminal foo would enable you to find the flag in a single command. Okay, single command. Okay. Using your own computer, you could use QEMU to boot from this disk. Okay, we'll try to use QEMU. Okay, right now I want to copy this link and let's clear and paste it here. Oh, I want to do some get file this image here. Okay, it's download now. Let's take a look the mission, the hint here. What's the terminal foo mean here? I want to paste it here and take a look the mission. And what's that mission is first grep. Wow, so we can using grep. So search string is, what is the search string is? Search string display printable string in file. Okay, do we have some search string here? Look like we are using here. Control C and man search string. The string display printable string in file. Okay, scan the entire file, not just the data section. So we can use the prefix option. Also strings. The Sleuth Kit is copyrighted by. Okay. So we can use the search string. Let's take the let's decompress the DDS pin. I want to decompress, so we add here the min d and listing the file and file DDS1. Like those MBR looks like the same thing but the different sector. Let's take a look about MMLS, the this. Still the same with the different length. And let's use search string min a the DDS. Okay, it's look like strings we are using in our mission. Let's using grep to check the pico. Okay, search string and grep the bin a here with the expression. I want to use pico ctf with the following character inside the bracket, and then we got the flag here, forensic neo python. Okay, we got our 2 mission here and our finishing our mission on Pico. Let's take a look. Is this the flag that yes, hooray, you are 110 points. And let's this sleuth number 2. Okay, before we are getting to the number 4, we are this Sleuth Kit. All we know is the file with the flag name is down at the bottom txt. Okay, this is the flag name down at the bottom .txt. This image is here. Okay, the Sleuth Kit has some great tools for this challenge as well. Sleuth Kit docs, there are so helpful. TSK Tools overview. Let's open here. And this can be also booted with Qemu. Let's copy link address and download it. We get the file. Booting with Qemu. I don't know how to use Qemu. Let's use Qemu. Let's use Qemu. Qemu. No manual entry. Execute file external command in alias suffix alias file directory. Okay, we got the DDS2 alpin flex image.gz. First, let's clear our hairs and like usual we decompress the file with the command gzip min the DDS2 image file. And let's take a look. We are DDS2 and using, let's first check the TSK Tools overview. Wow, nice dog. This page provides an overview of the command line tools like TSK. The TSK tools are organized into layers, and this page is organized based on those layers. TSK compare dir. Compare a local directory hierarchy with the contents of a raw device or this image. This can be used to detect a rootkit. Extract all the temporal data from the image to make a timeline equivalent to running FLS with the min-m option. Loads the metadata file system layer tools, fstat, show the file system, fffind, finds allocated and unallocated files name, metadata which ifind and ils and istat. This is mmls, mmstat and mmcat. Extract the content and specify the volume std out. What's the mission is? Down at the bottom text. Okay. What we do is mmls the dds2 alpine the image. Okay, let's set string. Src string. Search. Isn't it search? Search string. Oh, dds2 alpine and instead have the use the use our last syntax to check if the string is provided in here, and nothing we got here. What we can do? mmls dds2. We have the Linux partition here. The start is 0 to start sector. Okay, what we got is TSK Tools here. Image starts, image catch, and extract the content of the specific volume. Let's we use mmcat the dds2. This looks like need the image type. The image type is, let's check the mmls min e the dds2. Image type format use min e to list. mmls min e list. This look raw, the single split. Can we check the mmstat, the ds2, those file. Okay, so we can mmscat min e the those with ds2 alpine. We still have the min b sector size. Sector size is here. Okay, let's use min b here. Min b is sector size. Okay, still the use min e min o image offset. Okay, min o with the offset. What is the offset here. Offset sector is 0. Units of 512 bad sector. Is it the 512s? Partition table. Offset sector is 0. No. 512s? No, still nothing here. What's the problem here? I'll try with the MNLS. Let's take a look at the tools kit. These tools will show if the HPA exists. This layer contains tools for the image file format. For example, if the image format is spitting image of compressed image, this tool will show the raw content of the image. Emgcat. Let's take Emgcat the DBS2. Okay, what's this? Oh no. Am I doing something bad here? Okay, let's take a look. Wow, looks like I have the problem here. Wow. What's this? 2C1 here. Look like Image-Cat doesn't know. Okay, what we can do is we want to extract the file name layer tools find allocated or and unallocated file names that point to given metadata structure. Find list allocated and deleted file names in directory. Looks like FLS here. Wow. Image offset. Oh, I see. Let's check about the MFLS DDS2. Let's start again. Okay, we have a unit R in 5 units. This is byte sectors, so the sectors start with 2 0. The Linux is this is the meta with the length 1. I think let's have something here, and 0 to this is unallocated, and we are using the allocated file. So the start sector is 2.40x 2040x to this. Okay, let's use FLS DDS2. Can we use this? Cannot determine file system. We use min A display this and entry, min B display deleted files, offset into image file in sectors. Okay, we have to take a look the min O here with the length of this and paste it here, and we got home directory and directory lost plus found and file looking like R here, the Docker environment and bin directory, boot directory, dev directory. So the mission is here is all we know is the file with the flag name down at the bottom .txt. Okay, we can use FLS syntax here, and let's browsing about FLS command line. I'm sorry, I can common examples. FLS Sleuthkit. What is this? Okay, metadata address. Oh, this file. FLS min R min M slash image data to body.txt. The min M argument cause the data to be in the body file. It is used to make timeline an example. What is this? FLS image to dd slash to body.txt slash symbolic link. A directory regular file. R is a regular file. We got here the regular file here, and how you can explain here. We always got here. And what this number for? Can we use that number to the, let's try 12. Cannot determine the file system. Okay, what's that? Yeah, use yourself. Nothing here. Okay. I think a null byte on the first is not to functionality system. Let's try the the root system here. Can we offset from to the root folder? Cannot determine the file system. Oh no, what's about this? Oh, down at the bottom txt on the root folder. Okay, we got her. We got the numbers is here. Can we do some here? Error extracting file from the image. Error reading directory content. Reading directory content is the key. Now let's try here reading. Let's we find his read. iStat. We can use iCat extract the data units file which is specific by its metadata address. Okay, let's because iCat. What is iCat? Image offset still used photo. iCat we have offset here and about to 2018, and the image name is DDS2, and let's use the file here. What we got here? Yes, we got the Picoctf forensic cutter. Let's call the this system. I will copy here. I will open my other terminal, and in my other terminal I will open the code here, and our Visual Studio Code is open. Looks like something not good. Why it's not open in here? I want to change to the desktop Picoctf and do some forensic, and I will do cd forensic and this thing here. I will make the border here. Let's say autopsy and CD autopsy and code here. Okay, let's open the new file here. Let's say flag.txt and password paste here, and I will grab this line and Command F to find this line. I want to replace it with nothing, all replace here, and this line I will replace with nothing, and this line I will replace with nothing, and this line I will replace with nothing, and this line I will replace it with nothing, and other space here I will replace it with nothing, and the space is replaced with nothing. So we got the image. What we got here? Okay, we got the Picoctf forensicator novice. Let's copy this image and save here and paste it to our team. 130 point. Let's submit the flag and hooray, we are next. The last mission about the Sleuth Kit Apprentice. Let's check about this one. Download this image to find the flag. Okay, if you are using the website, download this image. We have nothing here. And find the flag. Looks like we are using the same command with the last mission, but we are using we must to search all the flag type. Let's copy link address and I want to let's clear and clear, and we get the flag here. This image, this flags.image.gz. Okay, gz. Like our last mission, let's extract or decompress this flag image.gz here, and let's clear again and let's use an MLS this image, this flag image. Okay, we have 3 partitions here, the Solaris, the Linux, but we want to do some research to check one by one. Let's take a look about this start offset. Okay, I want to use the FLS min O with the 2084, this dot flag image. This look like a Visa Kemu, the Linux system. Config virtual is look like a boot directory, and it doesn't have something. This is a file, just one directory lost and found. Let's find, take a look the 11, and there's nothing in lost plus found folder. Let's take the Linux swap folder. Swap directory is nothing here. Let's check it. Cannot determine the file system type. And I copy drag the start 20, 68 and 48. The file system type is the Solaris XX2. Let's take a look at this one. This is look like the familiar with us and the home directory. Let's take a look the home directory here about the 451. Nothing. Host and boot and etc is 1985. Oh, this look like .apk. It's file here. Shadow pass. Can we use grep to using here? Let's grab the nano rc. We can use grep. So I want to use ffls have the recurse, so we can recurse the all entry here. So we can use the min r here and min o. What's the size of the objects here? And this one, this flag.image, and I want to grab flag. We got the flag unit.txt and we got the flag.txt in real-alloc with the pointer to the sector about the 2082. Let's use our last command is using icat. Okay, we use icat min offset with the here with the this flag.image here, and the sector is here. Realloc. Why? Flag.txt. This look like the same here. Uncap. This is the file with the realloc plus. So this file, is it the 23 flag unit.txt 23 and 71? Oh yes, Picoctf byte server. I almost got the flag.txt, but the flag.uni. What is this one? The one or Let's copy and paste it here. Let's check the Sleuthkit apprentice. Okay, we have the 200 point here, and look like there's nothing here. We get nothing Sleuthkits again, and yes, so I hope this enough for today. Thank you for watching, and what you get is about the autopsy system. You can leave me a comment below or on my YouTube channel. Thank you for sharing, and don't forget to be like and subscribe my video to keep supporting me. Okay, thank you for watching.